Hello, ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. This is section 1.8, an introduction to functions. So the first thing we're going to go over is the definition of what a function is. And then after that, we're going to go into something called the Cartesian coordinate system and spend some time with my good friend Rene Descartes. Just remember, never put Descartes before Dehorse. Intro to functions. What is a function? A function is a relation. Let's write this down. A function is a relation where every input has exactly one output. A function is a relation where every input has exactly one output. A function is a relation where every input has exactly one output. A really great example is Major League Baseball. Because, hey, let's face it, I love Major League Baseball. Watch it all the time. And in Major League Baseball, we have teams such as the awesome Mariners, who have never gone to the World Series, and the equally awesome Washington Nationals, who also have, never gone to a World Series. And then you have teams that have been to the World Series too many times, like the Yankees and the Cardinals. And then you have teams that have been to the World Series a bunch of times but didn't win it, like the Braves. And some that just haven't been there in like 100 years or so, like the Cubs. And then ones that just beat the Yankees all the time, like the Red Sox and the Tigers. Now, all of these are broken into two divisions. One division is called the American League, and the American League has the designated hitter rule. And then you have the National League, which does not have the designated hitter rule. And what we are going to do is we are going to associate our input or our domain, which is the teams, with an output, which would be a range, which would be either the American League or the National League. Now the Mariners, they happen to be part of the American League. The Washington Nationals happen to be part of the National League. The Yankees are also in the American League, while the Cardinals are in the National League. Now on top of that, the Braves are in the National League and the Cubs are in the National League, while the Red Sox are part of the American League and the Tigers as well. So what we have is we have 8 inputs: Mariners, Nationals, Yankees, Cardinals, Braves, Cubs, Red Sox, Tigers. And we have 2 outputs. We have American League and we have National League. But if you'll notice, every input goes to either the American League or the National League, but never both at the same time. What this tells us is that every input has exactly one output. That means this is a function. Now, what would happen if I put in a new team called the Milwaukee Brewers and the Houston Astros? The Milwaukee Brewers and the Houston Astros have been in both leagues. The Brewers were a part of the American League for a long time before they were asked to move to the National League. And then because the National League had, I think, like 6 teams or 5 teams in the Central Division, the Astros were asked to move to the American League West, which only had 4. So the Astros have been in both the American League and the National League. So what does this do? Well, it breaks it. It's no longer a function because we have 2 inputs that have more than one output. But if we remove them and instead put in The Prospect Cougars. Well, we're not in the American League, and we're not in the National League. So we don't have an output. Now we have an input that has no output at all. This tells us that this is no longer a function because not every input has exactly one output because the Cougars are neither in the American League nor in the National League. Sorry, guys. So a function is a relation where every input has exactly one output. And then I said after we were going to do that, we were going to spend some time with my good friend Rene Descartes. And we are. Rene Descartes is very famous for the quote, "I think, therefore I am." He was a scientist, he was a mathematician, and he was a philosopher. He grew up in France in around the 1500s, mid 1500s, or sorry, late 1500s, 1596 to 1650. So he was a pretty cool cat. I like him a lot, mainly because I get to make fun of his last name with Descartes. Never put Descartes before Dehorse. You know, I already used that one. I know. Such is life. This is why I'm not a stand-up comedian. In fact, this is why I'm not even a sit-down comedian. Anyway, Rene Descartes created a system for working with functions called the Cartesian coordinate system. Cartesian coordinate system. What he did is he took two number lines and he put them orthogonally or perpendicular or at a right angle of each other. He had one that would go up and down, and he labeled this one as the y-axis. And then he had a second one. He had a second one, second number line, that's going to be way too big, that went through the middle horizontally, and he called this one the x-axis. So why did he call the x-axis the horizontal one? Because he, like everybody else, understands that we want all of our x's to be horizontal, preferably with 6 feet of dirt on top of them. So the x-axis is horizontal, and then the y-axis is vertical. In the middle is a point called 0, 0. This is the origin. This is where you start. So we always start in the middle at 0, 0, where the x-axis and the y-axis intersect. And when we do this, it breaks it into 4 quadrants. Kind of like in Star Trek, how you would have things like the Alpha Quadrant, etc. Well, so too do we have quadrants with the Cartesian coordinate system. Except instead of calling them the Alpha Quadrant, which is really Greek, we're going to call them quadrants 1, 2, 3. Can you guess what the 4th quadrant's going to be called? No, it's not going to be called. No, it's going to be called 4. God, why would you want to name it LeBron James? Where'd you guys get up with that? Anyway, quadrant 4, right? We have quadrants 1, 2, 3, and 4. And note how they go in a counterclockwise fashion. That is because way back in the day, they used to measure angles counterclockwise. For an example, here's my angle. If I wanted to measure it, I would start on this leg and then I'd go up like that, and then that would give me my angle. So too do we keep that fashion and we still go in the counterclockwise direction when we're labeling these. So quadrants 1, 2, 3, and 4. Which leads us to the next part, which is how are we going to use this? Well, to use this, we use something called ordered pairs to denote location. So we use ordered pairs to denote location. Ordered pairs are in order. They always have two numbers, and the first number represents where on the x-axis we are located. The second number represents where on the y-axis we are located. And going back to the function, that would mean that the x is the input and the domain, while the y is the output or the range. So if I was given the coordinate point 3, 2, I would know that the 3 tells me where on the x-axis I'm going. So I would go to the right 1, 2, 3 locations, 3 spots. So I know it's going to be somewhere on this vertical line at 3. I don't know where yet, but I know that it's going to be somewhere in that area. Then comes the second point. The second point is 2. So that tells me that I go up 2 on the y-axis. 1, 2. And there's my location. Here I've gone 1, 2, 3 to the right, as per my instructions, and then up 2. So this would be the Cartesian coordinate point 3, 2. But what about negative numbers? Well, let's try the point -2, 1. The -2 tells me that I'm going to move on the x-axis in the negative direction. As before, to the left is negative, and if we're looking at an up-down, down would be negative. So this -2 says that I move to the left 2 spaces, and then I go up 1 space and make my point. So this would be -2, 1. What if they're both negative? What if I have -3, -5? Well, then I go to the left 3, 1, 2, 3, as per the -3. And then I would go down 5 per the -5. 1, 2, 3, 4, 5. And there would be my newest point. -3, -5. By now you probably have figured out that we're going to have one in every quadrant. So where would the last quadrant be? Quadrant 4, not quadrant LeBron James. Yes, we would have a positive x like 2, and then a negative y like -3. So I go to the right 2, 1, 2, and then down 3, 1, 2, 3. And there would be my point, and that point would be 2, -3. So this is a lot to take in. We have this new thing called the Cartesian coordinate system. We have the x-axis, which is always left-right. We have the y-axis, which is always up-down. And we have ordered pairs to denote location. The x-axis will always represent the input, and the y-axis will always represent the output. So I guess we should probably put some applications in and figure out how to use them before we start working on our homework. So one of the applications for this is to visualize what's happening over time with something. For an example, let's say that we are going to have a party. And we're throwing this party, we're throwing this dance to be a fundraiser for something that we all want to do. I don't know what we all want to do, but something. Maybe it's a fundraiser for pizza parties or something. I don't know. Anyway, so tickets go on sale to this party, and the tickets are $3 each, $3 per person. And what we want to do is have a starting fund that we already have. And we have a starting fund of $75 in the bank. Now the question is, how much total do we have after the party? Well, to answer this question, we would first have to know how many people go to the party, how many people buy a ticket, right? And we're going to assume that the $75 is after all the costs of the party, right? We have $75 in the account after we start the party, and it's $3 per person to go. So how much would we have if only one person went to the party? Well, if only one person goes to the party, we get $75, because that's how much we have in our account, plus 3, how much we get for one ticket, which gives us $78. What if 2 people go? Well, then we would have $75 to start with, plus $3 for the first person. Wow, my handwriting is horrible today. Plus $3 for the second person, which would give us, let's see, 6 plus 75, 81. What happens if we have 3? What happens when we have 4? What happens when we have 5? Well, the more we look at this, the more people that go, the more money we're going to get. Now, originally back in the day, they would just make a huge chart to show all of this. And that list would be really long, really complicated, and not very intuitive. We wouldn't be able to look at it and go, oh, I know exactly what's happening. So when Rene Descartes created the Cartesian coordinate system, he revolutionized how this data was represented. What we would do is we would have a graph, and our graph would look something like this. We would have a vertical line to represent our x-axis, a horizontal line, or sorry, a vertical line to represent our y-axis, a horizontal line to represent our x-axis. And then in this situation, because 75 is such a huge number, we would skip a whole bunch of stuff in the middle. So to show that we're skipping a bunch of stuff, we use this little squiggly line to show that it's a truncated line, that we have removed a great deal of the numbers. And wow, that is really bad. All right, come on. Well, you can do this. All right, here we go. And what we are going to do is we are going to graph our situation. We have a situation where our output, or how much money we have at the end, is equal to 3 times the number of people that go plus 75. So I'm going to start out at 75 here. And then I'm going to go up by 3s. So 75 plus 3 is 78, 81, 84, 87, 90, 93, 96, 99, and I'm going to stop there. The x-axis is going to represent how many go. The y-axis is going to represent how much money we make. So if only one person goes, how much money did we make? Well, if we look at our equation here, we'd say y is equal to 3 times the number of people that went plus 75. We already did this. This was 78. So I make a dot at the point 1, comma, 78. 1, comma, 78. Now what happens if I plug in a 2? Well, we already did that earlier, and we got 81. So I go to 2 and then 81. What about 3? What if 3 people go? Well, that'd be $84. What if 4 people go? Well, that'd be $87. So, do we see a trend? The answer to that question is yeah. We totally see a line that goes up and to the right at a rate of 3 up for every 1 over. So, using this line, can we figure out when we'll have $100? Sure. We can estimate it by looking at the $100 output coming over and then going down to find out what the input that coincides with it is. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, about 9 people. As long as 9 people go, we'll have $100 in the account at the end. What if only 4 people go? Well, if I didn't want to have to, or let's say 6 people go, right? I wouldn't want to have to do the arithmetic for it. I could just go over to 6. 1, 2, 3, 4, 5, 6. Go up right here and across 93. So the graph visually represents what's happening in the function, and that is the power of graphs. They can be difficult to get down, but once you get them down, they make data so easy to access. They make trends easy to see and interpret. They make everything so much better. There is no scientific job out there that does not use graphs. There is no business job out there that does not use graphs. In fact, I'm a teacher, and even if I was not a math teacher, I would still be having to deal with graphs. Graphs are everywhere. We have to get them down, and we can all thank our good French friend, Rene Descartes. So here's our homework. For tonight, it is going to be section 1.8 on page 55. And we are going to be looking at numbers. Actually, it doesn't start on 55. My apologies. It starts on 57. And we're going to be looking at numbers 3, 5, 7, 11, 13, 15, and 27, 29. I feel like, yeah, I'm going to take 29 off. You guys aren't ready for that one. I think that'll be it. So it's only 1, 2, 3, 4, 5, 6, 7 problems. What did I tell you guys about what happens when we only have 7 problems? Yeah, they're gonna be hard. And I need you to, of course, show your work. If I don't see any graphs on your paper, then there's probably something wrong. You need to show your work. All right, that'll be it. Good luck and have fun.